Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6A in the great state of Texas, and we are using item number 12 off the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So the table shows some ordered pairs that belong to a quadratic function of h. What is the range of h? Well, what do we know about these things? If we know if it's a quadratic function, right, we know it's going to look something similar to this. ax squared plus bx plus c. We call it a quadratic because it has a degree of 2 or an exponent of 2 right there. And we know that the domain and range for our quadratic is going to be very similar to the domain and range of our linear functions that we also learn about in Algebra 1. So the domain is all independent variable values. And so that's typically going to be our x values. And then we are looking for the range. So that's going to be all, and then it's this right here, dependent values. Now sometimes they are the y values. If we're going to graph it, we are going to look at it on the y-axis, but in this case it's not even the y values, it's the h of x values, but they're the dependent values. So when we're looking for the range, right, we've got sometimes an equation, sometimes a graph. In this case we have a table. So what can we do with this table? Well, let's see if we could just kind of ballpark some of these points. We'll see this parabola, because that's the shape of a quadratic, is a parabola, like a U. So if we get this, this x and y is not very big, right? So we get the -4 and we get the 6. Let's just kind of put that there. So I got a -4, and well, that h of x is 41. So we're not going to count by ones up here, but we'll put this 41 right up there. Then we got a -2, and that's going to be 17. So that's going to be about halfway down, a little bit more than halfway down. Then we've got a 0 and a 1. So that's basically right there, just a hair above the origin. Then we have a 2, -7, so we're still going down. Not as much. And then we get a 3, look at that, -8. And then 4 goes back to that -7. And then 6 goes back to that 1. All right, so you see here, we are going down. We're going down. It's an upward facing, which means it's going to be, this is going to be a positive right there, that A, that you know it's upward facing. And we hit the bottom right there at this y equals -8. That's the bottom. That's our vertex. And that's what we're looking for, because when we find our vertex, we know that's going to be the bounds of our range. So our range is not going to be all real numbers, because you notice it never gets below that -8, right? All real numbers greater than or equal to -7, -8, or 0. Well, we're going to use this -8 right here. So we're going to say y is greater than or equal to, and then the bottom of that parabola is going to be that -8. So that's how we would show it mathematically. If we want to show it verbally or written out, we are going to take a look at that h right there. All real numbers greater than or equal to -8. Obviously this -7 is close. Doesn't get us, unfortunately, that -8. Not sure why we would choose all real numbers greater than or equal to 0. But it is going to be this h, because that is our vertex, and that's as low as it gets. And it goes back up. It would continue back up this way, you know, for infinity on this other side if we had more positive x values. So that is our answer H. All real numbers greater than or equal to -8.